Chris Gray, who is for the recording. I will start over. We're fortunate to have Chris Gray with us tonight. He is the Chief Technology Officer at RENU Communities, which specializes in retrofitting multifamily buildings without displacement of tenants. He oversees the evaluation of their programs, specifically their carbon neutral energy efficiency retrofit programs. And by way of background, he has a background in energy and engineering. He has a BS and MS degrees in mechanical engineering and a PhD in civil engineering, and is a member of the ASHRAE Board of Directors. And we also have visiting tonight two of his colleagues, Henry Nearing and Tiffany Nguyen, who you may notice also on the Zoom. And Chris, take it away.
Well, thank you so much. I appreciate you all joining. I appreciate the opportunity. I really, really love your advocacy mission. And it is very much aligned with what we do at RENU Communities. And so today I want to walk through our retrofitting process and give you some color and detail on how we retrofit multifamily buildings, because we focus on not necessarily affordable housing, but workforce housing, which is similar. And we are based out of Boston, Massachusetts. And so it's, I think it's very relevant what we do and the practices that we do. So RENU Communities was founded by our parent company, Taurus Investment Holdings. Taurus is a global private equity real estate company based out of Boston with roots in European energy initiatives and really the mindset of the Europeans when it comes to energy, because our current owner and two German brothers founded the company many years ago. And so there's always been an ingrained focus on energy efficiency within our company. And I like to make clear that I am not a real estate person. I am an energy person. I'm an engineer by training, as discussed, but I have a broad background in energy from working in utilities, working in research and development. I'm a licensed contractor, licensed engineer. So I can cover everything from the hands-on construction side all the way to the academic research side, and really leverage different components of that throughout my work with RENU Communities. But I joined Taurus about 3 years ago now to stand up this retrofitting arm that focuses on decarbonizing real estate under Taurus. So any asset that Taurus acquires, my team will go in and do a full evaluation of that property with a focus on reducing energy, increasing the efficiency, and decarbonizing that asset. So the reason that it's important and the reason multifamily housing is important is because of the inefficiencies in apartments. Typically, when an apartment owner buys a building, they do not care about the efficiency of the systems because they're buying an asset to create cash flow, and they want to put in the cheapest equipment that they can whenever it fails. And so there's no incentive for them to focus on the efficiency of the systems because the tenants pay the utility bill in a majority of situations. So the landlord is just focused on getting it built, getting it operating, and maintaining it at the lowest cost possible to maximize their net operating income. And in across the United States, over half of the apartment stock's over 30 years old. So over half of the apartments are built prior to 1990 with very different energy codes and have old inefficient systems in place, and it leads to those tenants living in those apartments paying higher than average energy bills. Apartments already have higher than normal energy bills per square foot because of the denominator effect. You have a smaller square footage, but you also have much more inefficient systems in an apartment that lead to much higher energy bills. And so it's an area that we at RENU focus on across the United States to decarbonize multifamily housing, because the sectors that we're operating within and what's called value add real estate typically is workforce housing. So it's the residents that really need the controlled energy bills, that need to be able to afford the utility bills for their apartments. The utility industry focuses on something shown here called the CRREM pathway, CRREM, that's Carbon Risk Real Estate Monitor, that projects for every asset class in the United States and really across the world. They project what energy intensity is going to be required over the next 30 years to hit a carbon neutral energy environment by 2050. So everyone talks about 1.5 degrees C or 2 degrees C global warming, and how do we control that rate of global warming so that we don't surpass 1.5 or 2 degrees of heating. Well, the CRREM pathway projects what's required on an energy intensity basis for every asset type to achieve that goal. And quite frankly, most buildings are nowhere near the level of achievement that they need to be. So the industry is taking that pathway and benchmarking buildings against it over time, and really requiring that real estate owners achieve a glide path along that reduction pathway. So as an example shown on the slide is one of our properties pre-retrofit and post-retrofit. Pre-retrofit, it was already pretty decent compared to the average multifamily unit in the United States, but post-retrofit, it's now good out to the 2030 energy intensity that would be required for multifamily housing as a whole. So what we're trying to do is make sure that real estate now has a much longer lifespan and that it is future-proofed from an energy and carbon standpoint. So when we go to retrofit a group of properties, it's a systematic analysis of the energy consumption of that property. So it starts with really an engineering analysis and energy audit. Many people have heard of an energy audit, where you look at where your energy budget is spent within your home, whether it be HVAC or lighting or heating or water heating. We do that same type of analysis for every building, whether it's a large multifamily community or an office building. We go in and do an energy audit so we know where the energy is being consumed. We then do energy modeling and evaluate what are the change cases that will allow us to make the most impact on that building. What are the costs of each of those potential change cases, and then what is the energy and carbon impact? And we're ultimately looking for the best package of solutions for that particular asset and that particular building. We then tie that together with monitoring and energy management systems, because it's one thing to go in and replace a piece of equipment and assume that you've made a difference, but it's another altogether to go in and implement a full retrofit and then track that energy consumption over time for that property. So we think the energy management and the monitoring component of that is very, very important. So we want to achieve all of our 4 major goals when we take on a retrofit. First and foremost, reducing energy consumption and eliminating the fossil fuels associated with that energy consumption. We want to electrify the property and remove any on-site fossil combustion. And when we do that, when we replace these systems, we reset that maintenance baseline for a property. If you have old inefficient systems that you're constantly having to repair or constantly having to patch back together, there's a significant ongoing maintenance expense associated with that. And so when we replace the systems with all brand new equipment, you essentially zero that line item out and you're able to start new and start fresh. We then want to improve the overall comfort and the satisfaction of the unit for the tenants. If they are not more comfortable or more satisfied with their system after we leave, we've not done a good job. We want to make sure that their comfort level is improved along with their reduction of energy costs. Then the last thing, as I mentioned, that we want to do is tie that retrofit to a long-term tracking of performance so that we can go back and show that our building actually is tracking along that carbon reduction pathway that's required for a carbon neutral energy future. There's a number of different ways to achieve energy savings, and there is no one magic bullet. We believe it is crucial to look at every single building as a unique entity in and of itself. Again, we operate all over the country, and so a building in Orlando, Florida is going to have a very different energy profile than a building in Massachusetts. And so we really want to understand what are the drivers of that building based on its age, based on the systems that were installed, and based on its climate. So we have to do a thorough analysis of the individual circumstances of each building. But there are some general technologies that we look at applying to every retrofit that we do, starting with the envelope, looking at the insulation and the separation of the outdoors from the indoors. That energy difference, or the temperature difference between the indoor temperature and the outdoor temperature, is a significant driver of all of the energy consumption of every building. So when you look at the simple things like sealing the envelope so you don't have cold air blowing into your building, reduces the amount of heat that you need right off the bat. If you increase the insulation levels and reduce the amount of heat that's lost to the outdoors, it reduces the amount of heat you need. And when you seal that envelope and get it very tight, you then need less mechanical equipment. So you not only reduce immediately your energy needed to heat or cool your space, you also reduce the amount of equipment or capital that you put into the equipment to maintain that space at a certain temperature. We look at evaluating the mechanical system and replacing that with a heat pump. So a heat pump is basically an air conditioner that pulls heat out of your house and puts it outdoors, that can operate in reverse. It can pull heat from outdoors and it can put it inside of your house. And heat pumps can use the ground for heat exchange, and that's called a geothermal heat pump, or it can use the air for heat exchange, and that's called an air source heat pump. And those are technologies that allow us to replace natural gas combustion options. So we look at applying heat pumps on all of our properties. We then use that same concept of a heat pump to heat water, and we look at heat pump water heaters generally across the southern United States. Because of that, they produce a cooling effect, and that cooling actually helps benefit the environment in the South. Lighting is low-hanging fruit. That is hands down one of the easiest things to do. So we make sure that all the lighting is LED. The appliances should be Energy Star. And then we look at other fixtures like water, right? Water is a scarce resource, just like energy. We don't want to waste anything. And so we make sure to put in water efficient fixtures as well. And then tie that together with renewable energy on the outside of the building and an energy management system to track that over time. And so those are common technologies to most all of our furniture. As an example, Southwinds Apartments was a 404 unit garden style multifamily complex in Fall River, Massachusetts. This was actually the first project that RENU worked on. And we acquired it in 2016, but we started the energy retrofit in 2020. It was a very, very deep energy retrofit. If you're familiar with HERS scores, or home energy rating score, the pre-renovation score was about 170. So it was 70% higher than a standard 2006 brand new residential home, 70% higher energy consumption. Afterwards, we are getting HERS scores in the 30s. So we went to 70% less than that standard baseline. So we achieved an 80% energy reduction with a combination of every technology that I mentioned. We improved the envelope, changing out the windows, the doors, the HVAC systems. We pulled out the electric baseboard heating. We pulled out the sleeve air conditioners and we put in high efficiency heat pumps that were really designed for heating in the cold climates. We put in attic insulation. We changed out exhaust fans. We changed out appliances. We put solar on every single building in the property. We tied that together with an energy management system that allows each tenant to really look at their own energy consumption on a pseudo real-time basis. So it really was a fully involved and very deep energy retrofit to achieve those level of energy savings, but we wanted to show that it can be done. And it can be done really on a cost neutral basis to the tenants and the landlords. So we reduced over 3,800 tons of CO2 per year on that property. And it comes through a combination of each of those different technologies. So I try to tell people there is no magic bullet. It takes a full suite of technologies to be able to reach these deep level of energy savings. You can't just change out lighting. You really do have to start to look at the shell of the building. You have to start to look at the mechanical systems as well. These are some pictures of those retrofits. So these were the sleeve units that were in place before the retrofit. They were very old, inefficient, very noisy air conditioners that the property was replacing about 1/3 of them every year. So that's not only materials that were going in the landfill, that's labor that has to be used to replace it. That's refrigerant inside of those air conditioning units that were being landfilled, right? And so it's a really bad situation, but it's what you find commonly in multifamily units and workforce housing. And then you can see the baseboard electric heat, which was very expensive for the tenants to operate. We would find times where the baseboard heats were malfunctioning and they would stay on, so the tenants would just open the door in order to stay comfortable. But these doors originally were single pane, aluminum frame, very inefficient windows and doors that were very leaky, and you could literally feel the wind gusts coming in around the windows and doors. So we replaced those with all vinyl, all brand new double pane vinyl windows and doors throughout the entire property. And we put in these wall mounted ductless heat pumps. So these are Mitsubishi Hyperheat, and that Hyperheat means that they are really designed to provide very high quality heat in cold climates. So they're specifically designed for heating rather than cooling, but they do provide cooling as well. We have solar inverters on every building to tie solar into each particular building. And we went in, and this was the insulation level before the retrofit. So it was old, compacted insulation that was very uneven from years of people crawling up there to do work, kicking it around, whatever they needed to do. We blew in another R30 of cellulose insulation into every roof line. So a very involved, in-depth retrofit. These are some additional pictures of the before and after. So we did paint the buildings as well. It's part of that overall aesthetic and the tenant experience of the building. You know, it looked like a 1970s construction building before. And after we painted it and completed our retrofit, we think it looks like a much more modern building. But the retrofit is visible, right? I mean, the heat pumps required us to run refrigerant lines up the building. So it's not ideal, but we try to blend those into the aesthetic of the building as much as possible. And then you can see the solar panels, which the residents actually really enjoyed seeing on this particular property. So an aerial photo of the before up top and then the after down below. You can see solar on every building across the property, and that's almost 1.4 megawatts or almost 1,400 kW of solar on that particular property. So when we are dealing with the tenants, obviously we cannot take a property and completely vacate it and do our retrofit, and then have all the tenants come back. We would love to do that, but you would bankrupt property if you do that. This retrofit, like I said, took 3 years to complete. Some of that is because we were in occupied tenant units throughout the entire process. So the ways that we deal with occupied units across our properties, which every property we take on is occupied. We never are able to remove tenants and put them back in, even though that would be easier. But like I said, it's not realistic when you're a real estate company. So we try to use vacancy and rollovers when possible. So you get natural vacancy in apartment units from people not renewing their lease. And so whenever those come up, we'll immediately jump on those and get those retrofitted so that when the next tenant comes in, it's already complete. It's important that the residents know what's going on in their lease. So we actually give them acknowledgement that there's a retrofit that's going to happen in their apartment if it has not already been completed whenever they renew. So we communicate with them. We let them know multiple different ways that we are doing this energy project. So we use the existing units on the property to create a hotel space if needed. If we need to move a tenant from an occupied apartment for some reason, and we need their space for a week, we can move them into another apartment for a week on the property and create a hotel space so that we are manufacturing vacancies if we need it. At Southwinds, we actually operated in pretty much a majority of occupied apartments. We would go in during the day, work, have a cleaning crew come in, clean up at the end of the day, and then the resident came right back to their unit after work. So all the work happened in fully occupied units. Like I said, tenant education is huge. So we create flyers for every tenant to let them know what's going on, what the benefits are, but also what the scope of the retrofit is, so that they're informed as they see different crews on the property. And then we work hand in hand with the property management team. They're really crucial to making sure what we do goes off successfully, through communication with the tenants again, but also setting expectations with the contractors, letting them know what's expected when they come onto the property and what level of cleanliness is expected when they leave. I just want to touch real quick on ways that we fund these retrofits. Massachusetts is the best state in the country, I think, when it comes to effective and easily accessible incentives and rebates. Some of them that we use specifically are the SMART program, or the solar program in Massachusetts that allows you to get not only energy offset for the energy that you produce, but also an additional incentive to help pay for that solar investment. Alternative energy credits as well. Heat pumps in Massachusetts are recognized as renewable energy. And so you can get an incentive from the state for installing heat pumps. And we do that at our properties. And then the city of Boston is really pushing real estate owners to invest in energy efficiency and carbon reduction through BERDO, their building emission reduction and disclosure ordinance, which is basically a stage-gated pathway to hit certain energy intensity milestones over the next 30 years or pay a compliance payment. So one way or another, they're either going to have to pay up or they're going to have to invest in their building. So a really effective tool in creating carbon reduction. And there you've got another view of our flagship property, Southwinds, and some links there if you're interested of news stories that have been done about RENU. But I want to thank you for your time and open it up for any questions that you may have.
Thank you so much, Chris. Maybe you could stop sharing so that we can see each other and take questions. Please just raise your hand and
Therese.
Hi, I have a 3-family home in Brighton. And so I'm concerned about greenhouse gas emissions. How would I move forward with getting my property retrofit?
So I would contact your utility, start with them, get an energy audit completed, and they can connect you with contractors that would be able to implement their recommendations. That's where I would start. Now, granted, I worked for a utility, and I believe that they are advocates for their customers. And I know through working with the utilities in Massachusetts that they are very good about advising their customers on energy efficiency improvements.
So that would probably be through Mass Save. That would be like blown-in cellulose insulation.
It could actually cover the full gamut of the different technologies that I talked about. It can cover heat pumps, lighting, HVAC, insulation, weatherization. It can really cover the full gamut.
So for insulation and weatherization, it covers blown-in cellulose. It doesn't cover like spray foam. And so if you have an old building, I have a building from 1904. We don't even, every time we look at it, something goes wrong. So if we were to try to retrofit that building, do you think that the blown-in cellulose would be sufficient to then go ahead and get the tenants air source heat pumps?
You know, I would really have to look at that particular building because with spray insulation, you have to be concerned about what you're doing to the full envelope and the energy exchange of the building, right? Buildings do need to breathe to a certain extent. Yeah. So you have to be careful how and where you spray that insulation. And so I wouldn't say a generalized statement like that. I would say that weatherization is key. So focus on sealing your envelope, caulk your windows and doors, make sure you are putting insulation, make sure it's a really good job of installing the insulation. And that's your best approach to start with heat pumps, is make sure that envelope's done.
Therese, I'm gonna ask for some other questions now. We can come back to your situation. We clearly, can talk a lot about energy efficiency and giving people assistance in managing their own properties. Kathy, I saw your hand up early on. Can't hear you.
Yeah, my one question is, so what your company does then is only on properties that this other company, Taurus, has acquired? Is that how?
Correct. So we are a subsidiary of our parent company, Taurus, and we only work on Taurus.
So let's just say, for instance, I live in an apartment complex in Hadley. It's senior affordable housing owned by who knows who owns it now. But anyway, so the idea is to get Taurus to buy my building. I mean, how do you get from A to B here?
Yeah, I think you should start a conversation with your property management company about why it's important to you, right? I mean,
like they care.
Well, share
exactly what you described. Just pay us that rent,
And that's unfortunate. You can share a copy of this presentation with them, and maybe it starts a good conversation.
But they're going to be laying out some money for this.
Well,
I guess if they're acquired by Taurus, where does Taurus get all the money to do this?
So we're a private equity firm. So we source capital from family offices, high net worth individuals, et cetera, all around the world. But yes, it costs money to invest in new systems. But when you have incentives that offset that cost, when you have energy costs that you're offsetting, when you have maintenance costs that you're offsetting.
You don't have to sell me. I'm all for it.
And so every retrofit that we do is at least cost neutral to all parties.
Go ahead. Sorry.
That's why we don't have unlimited budgets that we deal with. So we do have thresholds of 30% minimum savings on energy that we meet for the property. But our goal is net zero, right? Our goal is to save all the energy, but we don't hit that because we have these return thresholds we have to meet to make sure that it's cost neutral.
Great.
So,
Thank you so much. I'm gonna cut in, let some other people go,
Okay.
Kathy, because we have limited time with Chris. Ariel,
Hi, a couple of things. It's helpful that you're clarifying that you're not a company that just goes around and does retrofits for all owners. One thing you mentioned was, well, first I'll just mention the mass save services are definitely uneven. I have a good friend who, didn't even get a thorough audit nor offered any incentives except a loan for her 14 units. And I'm just kind of nudging her, go
Wow.
back and get a different auditor, because that
Yeah.
person was not well trained and well informed. So don't give up. But I wanted to ask you specifically, Chris, when you talk about in your organization, there can be some kind of splitting of costs between landlords and tenants. I think you referenced that in your opening remarks. Can you say what that looks like? Because in this state, I, as a smallholder landlord or any size landlord, am not even allowed to share an electric bill with a tenant, even if we have a contract to do that. It's against the public health code.
Right.
You can't share a bill. So how do you split costs with your tenants?
Yeah, so your costs have to be recovered through your base rent in Massachusetts. And remember, we operate across the country, so we have to worry about what can be done in each particular state. In Massachusetts, if you are going to pass along any of the costs, it has to be done through your base rent. But you, as a property manager, have costs associated with your property through the maintenance costs and the capital reserves that you're going to have when that system does fail. So if you have to do an emergency replacement, it's going to cost you about twice what it would cost to do it proactively. If you plan that replacement and you do it in bulk and you work with Mass Save to get a rebate, then you can take that capital reserve that you have out there for system replacements and probably cover that proactive replacement of systems.
No, that is a good point for those who have anything in reserve. It's true. And I'll just very quickly mention to the first person who spoke, don't do spray foam. Cellulose is excellent if it's applied by a good installer that knows how to do an infrared test. The spray foam is incredibly toxic, and we've gone over this for our municipal buildings in our capital improvements committee in Montague. And, spray foam is only used in tiny, tiny amounts where nothing else can be applied. Don't do it to your rental property. Thanks.
Adele, and then Randy.
Why don't you go to Randy first?
All right, Randy.
Is the IRA having any impact on what you do and how you do it?
Really, really good point. And yes, I was going to touch on that. For single family owners, or for single family home owners, the IRA is a fantastic tool. Most of the energy incentives that were put into the IRA are focused on single family homeowners. And there are incentives for replacing your electrical panel to make sure that it's heat pump ready, for heat pumps, for heat pump water heaters, for any of these energy technologies. The IRA is a very powerful tool. It is not so much helpful to what we do because it's multifamily, right? And we can't take that credit on a per multifamily unit basis. What we can do is look at other components of the IRA that allow for investment in commercial buildings and multifamily buildings on a per square foot basis. And if we achieve certain levels of energy savings, then we can benefit from a tax deduction for those energy savings. But it's on a cost per square foot, not these large thousands of dollars that you've heard of in the IRA. Another beneficial component of that is the ability to share in the tax equity. So there are investment tax credits for solar that are 30 up to 40%, depending on the components and where all the components are from. And we can use that tax equity as an ability to, to sell that tax equity portion of our solar systems and use that to offset the installed cost of our solar. So that is probably the most beneficial part of the IRA to what we do.
Mm-hmm. Okay. Thank you.
Adele?
I was going to ask about the South Winds project. And in particular, you mentioned sealing around the windows and doors, et cetera, but did you also add insulation to the walls?
We did not add to the walls. The walls were okay. We did add to the roof line of every building. So when you have stacked apartment units like that, your exterior walls are not as much of a driver of energy consumption as the leakiness through your windows and doors and the heat loss through the top floor attic. So it was a cost benefit analysis of drilling every wall cavity and pouring insulation into each cavity versus adding the cost in other areas to save energy. So that's where it comes down to our full energy analysis and energy modeling and cost benefit analysis to determine where the money's best spent.
Thank you.
Sam?
Hey, thank you so much. I wanted to ask, since we're talking about multifamily and energy efficiency, and I know that that you are an expert at HVAC, I'm thinking about the city of Boston specifically, and I'm thinking about college dormitories, because obviously we talk about multifamily units, but I'm thinking about right now in Boston, there's a trend that they want to change over some hotels and make them studio apartments. They're talking about possibly adding more dormitories. And so I'm not sure. And the reason why I'm asking this question is because we also know that our Boston public schools are not retrofitted for HVACs, but I want to stay on topic with commercial and multifamily units. So is there some correlation to maybe renovating or retrofitting a dormitory or a hotel into multifamily units?
Yes, there's correlations of everything I talked about with assisted living, with dormitories, and with hotels, just simply because of the resident nature of the building. Again, it comes down to each individual building as to what you can do and how you do it, and what the existing systems are, and really what the electrical distribution infrastructure looks like. But I could definitely see opportunities for turning dormitories into multifamily, or dormitories into hotels, or vice versa. You know, it's really about the layout of getting multiple residents into their own occupied space safely, securely, and healthily. And the heat pump technologies, there are just a tremendous number of different technologies that are adaptable to each individual application. So you have mini splits. A lot of people have heard of mini splits. That's what you saw at South Winds, where you have one outdoor unit to one indoor unit. You have systems that are called multi-splits, where you have one outdoor unit and multiple indoor units to cover, say, for example, the whole side of a house. You have what's called variable refrigerant flow commercial systems, which is one outdoor system that can serve up to 48 indoor zones. So you have a number of different system types that could be applied.
Thank you.
Chris, thank you so much. I know that we could talk a longer time, and but we promised we'd get you out of here around now, and we do have some other things to get to. But
I greatly appreciate the opportunity, and thank you for the questions. And I will make sure to get you my contact info if you have any follow-up questions. But thank you all for what you do. Thank you for your mission. Have a great evening.
Thank you so much. And if we could get a copy of your presentation, we'll share that with people. So
We'll
have
make
some
sure to do
to-
that.
thank you so much.
Absolutely. Thank you all as well.
Thanks.
Great.